Hello, in this video we are going to graph a linear function that is already written in slope-intercept form. The slope-intercept form of a linear function looks like this: y equals mx plus b. In this form, this m here is the coefficient of x and represents the slope. This b here is a constant that represents the y-intercept. Y-intercept simply means where the line will intersect or touch the y-axis. So, when an equation is already in this slope-intercept form, graphing that equation is easy. This is the origin. I am going to take an example to graph the function y equals negative 2x over 3 plus 3. So, comparing it to this form y equals mx plus b, that tells me that my m, which is the slope, is negative 2 over 3. The slope tells us how to move on the coordinate plane, as we are going to see. But where do we start? We will start at positive 3, which is the y-intercept. So the y-intercept occurs on the y-axis. I will go to the y-axis. My graph doesn't have numbers, so I'm going to use 1 square to represent 1 unit. So this is the origin. I start by plotting a point on 3, positive 3 on the y-axis. Now the slope says negative 2 over 3. Remember, we learned that slope means rise over run. So this negative 2 comes from the rise. The rise could also be a drop. If the numerator is negative, the rise could also be a drop. So this negative 2 means we are going to drop 2 units, and this 3 means we will go to the right 3 units. So we start here, we do a drop of 2 units, we go down 2 units, we go 1, 2. We don't put a dot right here. We have to go to the right 3 units. So we go 1, 2, 3. This is where we get another point on that line. And then we can do one more. We go 1, 2 down, 1, 2, 3 to the right. We get another point right there. We don't have any more room to continue getting points. So this is already showing us that we have a straight line as these points line up. So the next thing is to get a ruler and link the points up to get a straight line. And so we have a graph of that line. Two things to note. Use a ruler to draw the line, because the line doesn't stop on the points. The ruler will align the points to produce even more points if you have more room on your graph. So do not draw your line to stop on the points. Draw your line to cover the entire graph space so that you can cover some points that you probably did not plot them. For example, we could get a point here by going backwards. We've been dropping, so if we want to go backwards, we go up 1, 2, and then we go 1, 2, 3 to the left. So there is a point here. So if we extended our graph all the way, we see that it hits that other point that we didn't even plot. So always draw your line to cover the entire graph space so that you can hit points that you did not plot. So this is how we can use the slope and the y-intercept to graph the equation that has already been given in slope-intercept form.